Okay, here's our rule for adding rational expressions, which is exactly the same as the rule for adding fractions in the real numbers. And if we have a common denominator here, a over c plus b over c is just a plus b over c. And if we don't have a common denominator, we create one. We have a over c is equal to a times d over c times d, plus b over d is bc over dc, and then now we have a common denominator and we can just add the numerators here. And we can also have a little overlap here and create the least common multiple of c and d, and that will also work. So suppose I want to add these rational expressions. So here we have two rational expressions, x minus 1 over x minus 3, and I'd like to add that to 1 over x minus 3. And now the denominator is the same, so according to the first rule, this is just x minus 1 plus 1 over x minus 3, and those 1's cancel, so that's just x over x minus 3. The second one, x minus 1 over x minus 3 minus 1 over x squared minus 9. Now, as I mentioned before, when dealing with rational expressions, it's much easier to see what's going on when you factor the polynomials. So here we have x minus 1 over x minus 3 minus 1 over, this is an a squared minus b squared, so it's x minus 3 by x plus 3. And now I can either multiply these, but I see that x minus 3 actually divides this, so that is a least common multiple of these two denominators. So I can create a fraction with this least common multiple. And how do I do that? Well, I have x minus 1 times x plus 3 here over x minus 3 times x plus 3, and that's the same as this one everywhere except that x equals minus 3, minus 1 over x minus 3 times x plus 3. And so now I have x minus 1 times x plus 3 minus 1, and now if I like, I can expand this and subtract the 1. So I get that this is x squared plus 3x minus x minus 3 minus 1 over x minus 3 times x plus 3, and that's equal to x squared plus 2x minus 4 over x minus 3 times x plus 3. Okay, so when we have a common denominator like this, some people like to calculate when you're adding. You can say x minus 3 into the denominator is x plus 3, and you multiply that by the numerator here to get this first component of the numerator when you're amalgamating. And here we have the denominator, this denominator divided by this one is just 1, and so you multiply 1 by the numerator here. Now this next one has two variables, x and h, And something like this is going to appear very quickly in calculus when you're calculating limits in order to calculate derivatives. This h will be a very small quantity, and you will take a limit allowing h to go to 0. So you'll have to be able to manipulate fractions like this to calculate difference quotients. So how do I add these two fractions or subtract them? I need to create the common denominator, and that's x times x plus h. And then we have x plus h into this quantity goes x times. In other words, this divided by x plus h is x. So I multiply that x by the numerator there, that's x times 1 minus x into this quantity, or this quantity divided by x is x plus h, and it's minus 1 times x plus h. And that's equal to x minus h over x times x plus h. And those x's cancel, and that's equal to minus h over x times x plus h. If you're a little unsure of this calculation, you can always write this as x times 1 over x times x plus h minus x plus h times 1 over x plus h times x, and now you have the denominators are the same, and you can just subtract to get this quantity here. Okay. Sometimes we have expressions like this. As I mentioned in calculus very quickly, we have difference quotients that look a lot like this, and sometimes we want to simplify these, figure out if there's any cancellation, and then we'll want to calculate limits. So here we have a difference of two fractions over a difference of two fractions, so over a sum of two fractions. So in order to figure out what this is, we have to first add those fractions. So 1 over x plus 1 minus 1, the common denominator is going to be x plus 1 here. And we have 1 over that minus, well, 1 into x plus 1 goes x plus 1 times, so it's going to be minus x plus 1. This is minus x plus 1 over x plus 1, which is 1. And here we have x minus 2 over x minus 2 plus 1 over x minus 2. So that's going to be x minus 2 times 1 plus 1 over x minus 2. And that's equal to 1 minus x minus 1 over x plus 1, all divided by x minus 2 plus 1, so that's x minus 1 over x minus 2. Now, these 1's cancel, so I have minus x over x plus 1 over x minus 1 over x minus 2. Now I invert this fraction, and I have minus x over x plus 1 times x minus 2 over x minus 1. And that's equal to minus x times x minus 2 over x plus 1 times x minus 1, and of course I could write this as x squared minus 1 if I felt like it. This one has an a and an h in it. Both are variables, and I just treat them as if they were numbers. So I first have to add this fraction. I create the common denominator, a plus h times a here, and a plus h this divided by a plus h is a, so I multiply that by the first one, so it's a times 1 minus this divided by a is a plus h, so it's minus 1 times a plus h. So I divide that by h, and now this is a times 1 minus a minus h, so that's minus h over a plus h times a all over h, which is really h over 1. And now I invert this fraction here, and I get minus h over a times a plus h times 1 over h. The h's will cancel, and that's equal to minus 1 over a times a plus h. And our last trick, essentially, which is very commonly used in calculus, is rationalizing either the numerator or denominator. In particular, when we have a square root like this and we want to replace this whole thing by a polynomial in the numerator, then we can perform this trick. We have the square root of a minus the square root of b times the square root of a plus the square root of b is the square of that minus the square root of that, which is just a minus b. So if I multiply this by the square root of a plus the square root of b, then magically the square root signs disappear. And so that's the trick I use here. But of course you can't multiply the numerator by something and maintain equality if you don't multiply the denominator by the same thing. So let's see how we might use this trick. Suppose I want to make the denominator into a polynomial here, or rationalize the denominator. The trick is that I multiply by what I call the conjugate, the square root of x minus 1, which is the square root of x plus 1. Now the product of these two, so I get the square root of x plus 1 in the numerator, so the numerator becomes more complicated, but the denominator becomes simpler because this is the square root of x squared, so that's x, minus 1 squared, so that's x minus 1. I can use the same thing to get past the square root sign in the second expression. The idea is that I multiply by the square root of 9 plus h plus 3, that's the conjugate of that, but if I multiply by that to maintain equality, I must also divide by that. So this is going to make the numerator simpler, but it'll make the denominator more complicated. So now this is a, this is the square root of a times the square root of a, is just a, so it's 9 plus h minus, and the square root of b here is 3, so b is 9, so it's that minus 9 minus 3 squared over h times the square root of 9 plus h plus 3. Now you see these 9's cancel, and this is very simple. This is h over h times the square root of 9 plus h plus 3, and now if h is not equal to 0, that's equal to, the h's cancel, it's 1 over the square root of 9 plus h plus 3.